Hi, thank you for watching my video. I am uploading my videos to share with you what impressed me on astrophotography activities. In this video, I will show you my works of remote control implementations on my Raspberry Pi 5. I will use it for Fujifilm X-E1. I love this camera for its color, sensitivity, resolution and its low noise images. I have taken many night sky objects like M31, M42, M45, Horsehead Nebula, Rosette Nebula, of course the Milky Way, and many others. I enjoyed taking those images back then, but I kind of paused doing it. The biggest reason why I stopped doing it is because I needed to develop the images and process them afterwards on my PC, not in real time. As I have uploaded many videos of my astrophotography challenges using my Raspberry Pi, I can get the best image almost in real time. It is a very responsive way of capturing the night sky objects. I wished I could do the same with my X-E1. But the camera does not have any functions to be controlled from the PC. So I implemented the remote shutter control. I hope you enjoy the following video of my work. First, the X-E1 shutter release connector utilizes the 2.5mm audio jack. I have already bought the connector, just in case I checked the remote release connection. I can get the shutter opened by connecting the left channel and the ground or the common, or the shield wire of the cable. I bought this remote switch PCBs from Amazon. These two boards are identical but one has the indication of receiver, as this letter R is written by a marker. The remote switchboard requires 3.3 volts. So I got this DC-DC converter that generates 3.3 volts from a wide range of DC voltages. In order to build a prototype system, I soldered the pins so that I can use breadboards and check the functions. Then I soldered female pin connections onto the remote switchboards. The boards have 6 channels to control but I just need only one. So I selected channel 4 simply because of ease of soldering effort to be minimized. The soldering pads are so close to each other. It is almost impossible to solder by hand. Next I solder the 2.5mm stereo jack wirings. It is time to check the remote switch function. The transmission part is on the left and receiver part is on the right. When I bring the channel 4 to ground on the left, the LED lights up on the right. By the way, the connection between the two boards is the 3.3 volts and the ground to drive the receiver board. After I built an output part using a N-channel MOSFET, I connected the shutter release cable to check the real function using X-E1. It works fine. Good. I think I can use this system, so I continued implementing it to the Raspberry Pi side. Just in case I checked the bulb function as well. As long as the low state in the transmitter board, X-E1 keeps the shutter open. So I can use it for situations requiring long exposures. I use the pin 1 to 6 in the GPIO connector on the Raspberry Pi 5. You can see the pin assignment here. I did not use the GPIO 2 to 4. Just in case I need to use them in serial communication purposes in the future. So I soldered 3 wires from the pin connector to the receiver board. Finally, the test is almost done. I set the transmitter to the DC converter box where the 9 volts generated from USB. The 9-volt power is connected to the X-E1 DC coupler and also the 3.3-volt generator board. The GPIO output state is manipulated in the terminal with a simple command. Then I use this SD card with Wi-Fi connection. I need to change the Wi-Fi connection to this SD card. During connecting the card, I lose the internet connection. It is not so critical because I don't have any Wi-Fi network out in the field. It might be difficult to see the image frames are updated in the web interface. So I can control the shutter remotely and get the image data remotely. Lastly, I show you this neat idea of using the MagSafe feature to my Raspberry Pi 5. It is better than using the plastic case that I showed in my video previously. You might recognize the wireless HDMI on the Raspberry Pi. Yes, I am building a wireless system. This is the future plan for wireless systems, where X-E1 is now wirelessly connected to Raspberry Pi 5. The HQ camera is unfortunately wired with an HDMI extension at the moment. The control center, which consists of the display keyboard and mouse, is inside a thermal shield. I mean, I can control the cameras through the Raspberry Pi 5 from inside a house or a car, where I can feel warm in winter. I will upload the test report someday. Let's see how it goes. Okay, that's all for this time. Thanks for watching this video. See you next time.